My Patreon site is up and ready to go. The video you are about to watch is a sample of the content you will be able to access as a subscriber. I would love it if you would take a moment to check out my Patreon site. On www.patreon.com/deconstructionzone, I post chemistry and physics videos. Ready to print worksheets in PDF format with answer keys. Videos where I complete the worksheets with detailed explanations of how to work the problems. Plus much more. If you are a chemistry or physics student looking for study materials, then the videos and worksheets could be the thing you're looking for. If you are a classroom teacher, the materials on the site could be the fresh new take on the subject that makes things come alive for those difficult students. Also, I would love for you to take a look at the lesson plans and activities I post. And best of all, everything on my Patreon site is my original content and is yours to use in any way you see fit. If you are a homeschool teacher, chemistry and physics might seem a little overwhelming. The Patreon content could help bridge the knowledge gap and help your students get a better grasp of the subject. Please check out my Patreon site. Let me know what you think and how the content might be improved. I welcome all feedback. Also, if there is a specific topic you would like for me to cover, or a worksheet you would like produced, send an email to djthedeconstructor@gmail.com, and I'll see what I can do to make it happen.
Reviewing Order of Operations. This presentation was created for my Patreon supporters. Original content created by DJ the Deconstructor. Voices provided by MikeMonster.com.
Why do we need an order of operations? Consider the simple equation, 12 minus 8 divided by 2 equals some number. If I do the subtraction first, followed by the division, the answer is 2. If I do the division first, followed by the subtraction, the answer is 8. The order in which we perform our calculations affects the result. This is why we need an order of operations. Following the order of operations ensures that everyone will get the same result when they attempt to work the same formula or equation. I want to show you something sad, but true. Not all calculators are created equal. Here is an older, basic function calculator. It has the 4 basic functions: add, subtract, multiply, and divide. It also has a square root key. It doesn't do any of the higher math functions. Watch what happens when I enter our simple formula, 12 minus 8 divided by 2, in the order shown, from left to right. I enter 12, hit the minus key, and enter 8. Pay close attention to the display as I hit the divide key. Did you see it? As soon as I hit the divide key, the display changed to 4. The calculator evaluated 12 minus 8 and returned the answer, 4. Now as I enter the number 2, and press the equals key, the calculator displays the answer as 2. Now compare that to what happens when I do the same thing on my scientific calculator. I enter 12 minus 8 and then hit the divide key and the number 2. Notice the display. It's showing everything I have entered and has not evaluated anything so far. When I hit the equals key, notice that it displays the answer we should get when following the order of operations. 8. Advanced calculators have the order of operations programmed into them. But you may run across some basic function calculators that do not. It's important to understand the order of operations to ensure that you are always getting the correct answer. I have only tried this with Microsoft Excel and Google Sheets. The good news is that Microsoft Excel and Google Sheets have the order of operations programmed into them. Let me show you what this looks like in Microsoft Excel. I have a blank workbook in Excel. I click inside any cell and type the equals sign to begin my formula. I type our formula exactly as we have seen it, 12 minus 8 divided by 2, and press enter. Excel returns my answer. There's a simple mnemonic for remembering the proper order of operations. P-E-M-D-A-S. Please excuse my dear Aunt Sally. P, please, is for parentheses. E, excuse, is for exponents. M, Mi is for multiplication. D. Deer is for division. A. Ant is for addition. S. Sally is for subtraction. Parentheses are at the top of the order of operations list, PEMDAS. Everything in parentheses is to be done first. Parentheses are just one component of a more elaborate bracketing system, which includes angle brackets, braces, and parentheses. Brackets, braces, and parentheses are used to nest operations. If several operations are nested using only parentheses, it can be visually confusing. Notice what I'm showing you here. Open parentheses. Open parentheses. Open parentheses, 2 plus 3, close parentheses. Divided by 6, close parentheses, raised to the third power, close parentheses, divided by 4. Having all of those parentheses can be a little difficult to follow. But look how much easier it is to follow when some of the parentheses are traded out for braces and brackets. We now have open brackets, open braces, open parentheses, 2 plus 3, close parentheses, divided by 6, close braces, raised to the third power, close brackets, divided by 4. There are of course some rules for bracketing. Parentheses are the innermost operation. Always perform this first. Then come braces, and finally brackets. Let's work the bracketing example together. The innermost operation is inside our parentheses, 2 plus 3. I'll put 2 plus 3 into my calculator and press equals. Our answer is 5. The next operation is contained within the braces. The formula is telling us to take our answer from the parentheses, 5, and divide it by 6. And our calculator returns 0.83, with infinitely repeating 3's. We move to our next level, the brackets. The brackets are telling us to take the answer we just got and raise it to the third power. When I do that, we get 0.5787 with a repeating 0.37. Our final operation is outside of our brackets. We take our previous answer and divide it by 4. Our calculator returns 0.14467 and a long string of decimals for our final answer. When we see a formula, and there are no parentheses, it's a good habit to insert parentheses according to the PEMDAS rule. I am showing you 2 plus 3 times 8 minus 6 times 2 plus 4 equals some number. I could follow the order of operations and do this without taking the time to add my parentheses, but by adding them I'm making sure that I won't miss something. I'll go ahead and insert my parentheses now. You can see I've added parentheses around the 3 times 8, and another set on 6 times 2. That makes the calculations pretty simple, and I can do this one in my head. I do what's in the parentheses first, and I come out with 2 plus 24 minus 12 plus 4 equals 18. Let's take a look at a real-life example. You've just taken a job waiting tables at the local Italian restaurant. In the middle of your shift, the computer system goes down.
Oh no! Now I have to figure all of the customers' bills by hand.
At one table there is a party of 6. They had 2 appetizer platters at $9.95 each. 2 orders of lasagna at $11.59. 1 order of soup and salad at $9.99. 3 of the group went through the buffet line, which is $14.49 a person. The local sales tax is 8.52%. And the guests want to divide their bill equally. How much will each person have to pay? This can seem a little complex, but we can simplify this quite a bit by using the rules for order of operations. I want to start by putting down all of the components that go into making the customer's bill. For convenience sake, I'm showing it to you in a table. We have our appetizers. 2 at $9.95. Lasagna. 2 at $11.95. Soup and salad. 1 at $9.99. Buffet. 3 at $14.49. Tax. 8.52%. Number of people. 6. Before I do anything with this, I want to show you a little trick when it comes to figuring things like taxes and tips. Whenever you are calculating a percentage of something, instead of figuring a total, calculating the percentage, and then adding the percentage back to the total, I have a huge shortcut. Simply add 100% to the percentage rate, and multiply by that. For instance, if we have a bill for $100, and a tax rate of 10%, what will the total bill be? 10% of $100 is $10. Adding $100 and $10, we get $110. But what happens if we add 100% to our 10%? That makes the percentage 110%. As a decimal, it's 1.10. $100 times 1.10 is $110. When we get to our tax rate, I'm adding 100 to it so that I don't have to calculate my pre-tax total twice. I put that down in a formula. 2 times $9.95 plus 2 times $11.95 plus $9.99 plus 3 times $14.49 times 100% plus 8.52% divided by 6 equals some number. Now I insert my parentheses. I'm putting parentheses around 2 times $9.95 and around 2 times $11.95. Also around 3 times $14.49 and around 100% plus 8.52%. Because I want the tax rate to apply to the entire food order, and not just what is sitting next to it, I will add braces around everything that comes before my tax calculation. We can calculate this by hand, or we use a calculator. Everything in the parentheses will be done first. Then we will do everything within the braces. And finally, we will do what is left. Our answer is that each person owes $17.58. What I'm about to show you is not, strictly speaking, order of operations. But it will help you when working formulas and equations. It's useful to know fractions are just another way of expressing division. The line in a fraction means divide. If you take a common fraction like 4/5, that's the same as 4 divided by 5. This is helpful because sometimes you may want to rewrite complex formulas as fractions. Consider this rather nasty-looking formula. Open braces, open parentheses, 23 times 43, close parentheses, plus 16, close braces, divided by, open parentheses, 18 times 4 raised to the 5th power, close parentheses. That formula can be rewritten as a fraction. It is the same as open parentheses, 23 times 43, close parentheses, plus 16, all over 18 times 4 raised to the 5th power. To solve this, treat everything above the fraction line as though it is bracketed together, and treat everything below the fraction line as though it is bracketed together. Now solve this using the order of operations. According to our order of operations, we need to do what's inside the parentheses first. On the top line, inside the parentheses, we will multiply 23 and 43. That gives us 989, to which we add 16. That makes the numerator of the fraction 1005. Next we turn our attention to the bottom of the fraction. Following the order of operations, we do the exponents first. 4 raised to the 5th power is 1024. And we will multiply that by 18. The bottom of our fraction, our denominator, is 18,432. Our fraction has been reduced to 1024 divided by 18,432, which evaluates to 0.0556. I want to take a moment to talk about exponents. When an exponent appears next to a number, it only affects the number it is against. Consider the formula, 4 times 3 raised to the 3rd power. This evaluates to 108. We do our exponent first. 3 raised to the 3rd power equals 27. We multiply 27 times 4 to get 108. In the example, the exponent of 3 only applies to the 3 it is sitting against. 4 times 3 raised to the 3rd power is not the same as open parentheses, 4 times 3, close parentheses, raised to the 3rd power. That equals 1728. The parentheses make the exponent apply to both the 4 and the 3. Exponents are not always positive numbers. They can be negative as well. Negative exponents are reciprocals. A reciprocal is a function such that a number times its reciprocal always equals 1. As an example, 5 times 1/5 equals 1. 1/5 is the reciprocal of 5. 1/5 can also be written as 5 raised to the negative first power. If you need to prove it, try it out on a calculator. 1 divided by 5 is equal to 0.2 and 5 raised to the negative first power equals 0.2. Now that we have an idea of what reciprocals are, we can put that knowledge to good use. It can be helpful to rewrite negative exponents in their reciprocal form to make a formula easier to understand. Consider 3 raised to the negative fourth power. That is the same as writing 1 over 3 raised to the fourth power. Let's look at a formula. 3 times 1.4 times 3 raised to the negative fourth power. It can also be written as 3 times 1.4 times 1 over 3 raised to the fourth power. That's also the same as writing 3 times 1.4 all over 3 to the fourth power. 3 times 1.4 equals 4.2. 3 raised to the fourth power is 81. 4.2 divided by 81 is 0.052. In the order of operations, P, E, M, D, A, S, it looks like roots are not accounted for. But roots and exponents take equal priority. Consider the expression, the cube root of 27 plus 3 times 4 squared. It does not matter if you perform the root or the exponent first. The answer will always be the same. In this example, the answer is 51. The cube root of 27 plus 3 times 4 squared is the same as 9 plus 3 times 16. This simplifies further to 9 plus 48, which is 51. Roots can be expressed as fractional exponents. The cube root of 27 is the same as 27 raised to the 1/3 power. But what happens when the fractional exponent does not have a 1 on top? Let's change that 27 to the 1/3 power into 27 to the 2/3 power. 27 raised to the 2/3 power is the same as the cube root of 27 squared, or the cube root of 27 squared. They all equal 9 on a calculator. The thing to remember here is that the numerator is the exponent, and the denominator is the root. I have a very good reason for showing you the relationship between fractional exponents and roots. A lot of calculators have a square root key and a cube root key, but many do not have an option for other roots. This limitation can be overcome by entering the root as a fractional exponent. If we wanted to take the 7th root of 2187, we could do this by entering it as 2187 raised to the 1/7 power. The answer would be 3. This even works in spreadsheets. I open up my Excel spreadsheet, and in a blank cell I start my formula with an equals sign. Next I type my number, 2187. To get Excel to treat this like an exponent, I type the up caret key, located on the keyboard above the number 6. Next, so that I don't confuse Excel, I will enter my fraction as division, and I will put it in parentheses. I type open parenthesis, 1 divided by 7, close parenthesis. If I did this correctly, I should get the answer of 3 when I hit enter.
Woohoo! It worked!
I'm sending out a thank you to all of my Patreon supporters. I sincerely hope that you continue to find the materials I publish to be informative, useful, and entertaining. Follow me on my YouTube channel, Deconstruction Zone. If you would like to contact me, please direct your inquiries to djthedeconstructor@gmail.com. By the way, this is Sunshine. Sunshine wants you to like, subscribe, comment, share and hit the notification bell. If you don't, Sunshine will know. And, Sunshine will come to your home and deconstruct something. This is DJ the Deconstructor wishing you, happy sciencing.